Good afternoon, Paula. Today is 11th of December. We tried to log into Zoom for the meeting. I assume life happened and you were detained. So I'm attempting to record this video and send it to you, meet the requirement of doing the presentation. My presentation is on, go back to slide 1. My presentation is on safety of lasers. The course is ISAT 366. Again, my name is Wyndell Lee. History, early years of lasers. In 1917, Einstein laid the foundation for the laser when he introduced the concept of stimulated emissions. That's where a proton interacts with an excited molecule or atom and causes the emission of a second proton having the same frequency, phase, polarization, and direction. A little later on, a guy by the name of Charles Townsend, and I'll just say some other affiliates, he gave some of it, he was a professor, and he gave some of his students the task of figuring this laser problem out. By 1954, they had a working device that Townsend called the microwave amplification by stimulated emission of radiation, which was the previous version, the predecessor to lasers. Of course, by the time that hit the public, and a lot of other people were attempting to do the same thing. Several other independently organizations and people came up with the same type of open cavity concept, including the guy named Gordon Good, a graduate student for Columbia University. Good was also the first to publicly use the term laser. In an article he wrote in 1959 at the Ann Arbor Optical Pumping Conference. Good filed a laser patent in April 1959, but this was denied by the U.S. Patent Office in favor of Townsend, the previous guy I talked to, in support of his optical masser patent. This led to what was often called the 30-year patent war, where Good eventually won after winning 48 patents many years later. A guy named Theodore Mayhem developed the first working laser at Hughes Research Lab in 1960. And he wrote a paper that described the operation of the first laser that was published in a magazine called Nature 3 months later. Next slide. Before we go into the safety aspects, we'll talk a little about how lasers operate. And for the most part, I got two types of lasers. The optical cavity, which is the arrangement of optical components which allow a beam of light to circulate in a closed path to create gain. And you also have the pumping system, which transfer energy from an external source into a gain medium of a laser. Now, the mediums that lasers use in order to function, first one is solid state, which uses a solid as a medium. In these lasers, glass or crystalline materials are normally used. The first solid state laser that was used was a ruby, and you can imagine that became very expensive. So as time went on, different scientists and inventors came up with different methods of doing it. Another method was the gas. Gas laser is a laser in which an electric current is discharged through a gas medium inside a laser to produce laser light. In gas lasers, the laser medium is in a gaseous state. A good example of that derived from that is the incandescent light bulb. It's filled with gas and electric current is applied to it. You cause it to illuminate. And the next type is the excimer, pulse gas discharge laser that produces ultraviolet light. Another type is the dye laser, uses complex organic dyes in liquid solutions as the laser medium. And final type that we're going to talk about is semiconductor. These lasers are very cheap, compact in design, consumes low power, but they're also known as laser diodes. So you can call them so you can call them semiconductors or laser diodes. This slide shows slide number 4, which shows the spectrum of light in which lasers are used in. And it's the visible light range. Slide number 5. We talk about the 4 classes of lasers in sequential order from 1 to 4, with 2 having a subcategory and 3 having a subcategory. The precedence is from least impactful to most impactful. Category 1 emits little to no laser radiation and has no known hazard level. Category 2 and Category 2 alpha, low power visible lasers that emit above class 1, but at the radiant power not above 1 milliwatt. Category 3 alpha and 3 bravo are intermediate and moderate power lasers that can be hazardous if viewed directly. They can also start fires. Category 4 are high power lasers. They're hazardous, they pose potential fire and skin hazards. Slide 6 shows uses of lasers, which, for example, like the CD, DVD, Blu-ray printers use them, barcode readers use them, fiber optic systems use them. Some new technologies with lasers are, one is called Wi-Fi, like your lights in your house. Your wireless internet is transmitted through the lights to your device. The meaning behind that, only direct view of the light can access that Wi-Fi system. There's speaker systems that are laser powered, where the laser audio is pointed at the speaker and the speaker doesn't have any plugs or anything, and the power from the laser powers the speaker and you hear sound come out and everything. So laser has a lot of useful uses. Slide 7 In slide 8, show type of laser system called LiDAR. Is what NASA uses to map terrain above ground and below the ocean. And as you can see in the picture, the color differentiates from the altitude level or the depth level if it's underwater. Slide 9 is pretty much a LiDAR video showing how the laser scan works. And it bounces from the plane off the object back up to the plane. Slide 10, we talk about hazards, some of the hazards that lasers, well, public safety hazards about the lasers. Several organizations concern themselves with laser safety. A couple of the organizations, for example, are American National Standards Institute, the Center for Devices and Radiological Health of the Food and Drug Administration, Department of Labor, Occupational Safety and Health Administration, and the Council of Radiation Control Program Directors. And all these organizations are US based, and the one that seems to be the gold standard is the American National Standards Institute. The other organizations seem to refer to ANIS and as far as direction and compliance and developing local policies and procedures. Requirements are generally concerned with the registration of lasers and licensing of operators and institutes. When it comes to doctors, when using lasers for medical purposes, they're generally exempt at the state and local level. Now, NASA set forth the guidance for the other organizations to follow, but they don't provide a step-by-step, line-by-line approach as far as how the organization should proceed. And they kind of leave that up to the individual organizations, and with the expectation that if that organization needs additional guidance as far as safety and metrics about lasers related to health and the environment, they can contact NASA and they will be happy to provide that kind of information to them. The next slide is my references that I gained the data from. And my last slide is any questions. That concludes my presentation. Thank you.